Hey, Sam and Emma! Now that we know all about motion, speed, velocity, and acceleration, let's learn about force and work. Let's go to the playground! A force is a push or a pull. If a force causes an object to move, energy has been transferred to the object. We call that work. Let me introduce you to our energy friend, Freddie Force, who will help us demonstrate force and work.
Hi, kids. I love making things move. Let's go to the swing set.
When Sam and Freddie push Emma, they need to apply a force, a push, to get her moving. And because Emma moves forward, Sam and Freddie have done work.
Dr. Watts, how do we calculate force? Is there a formula we can use?
You betcha, Sam! The formula for force is force equals mass in kilograms times acceleration in meters per second squared. The units are kilogram, meter per second squared, or more commonly expressed as newtons.
So, when I move on the swing because Sam and Freddie pushed me, that's work?
Exactly! Work equals force times distance. If distance is 0, work is 0. In other words, if you apply a force, push or pull, and the object does not move, then work is 0.
If Sam pushes but the swing doesn't move, no work happens, just force.
But if Freddie helps to push and the swing does move, the force Sam and Freddie uses makes the swing travel a distance. That's work. The units for work are called joules, which is a newton times meter.
So, Freddie Force makes the push, and work happens when that push makes something move.
Do you want to see how we calculate work using a graph? Okay, here we go. This is a force-distance graph. The y-axis is force in newtons, and the x-axis is distance in meters. Suppose Freddie applies force to an object, and the more force he uses, the further the object goes. See the graph for an illustration. Freddie eventually applies 20 newtons of force to push the object 10 meters. To calculate work, you need to find the area under the curve, or that denoted by the blue triangle. Remember, area is 1/2 base times height. Thus, work equals 1/2 distance times force. In this case, work is 1/2 times 10 meters times 20 newtons for 100 joules in total.
Wow, we got to play on a swing and learn physics at the same time.
Now that's force and work, energy friends style.